Welcome to Study Loop.
We need to find the location of this point C relative to one of the other points. And we also need to find what the tension is at this point B. So we're going to start the problem by writing out equations for the lengths y of B and also for length y of A. So for y of A, we can write that as C times the hyperbolic cosine of negative x of AC divided by C. And this negative sign is here since we're on the left side of this origin point. So this is going to be a negative value. And then y of A, we can also write this as the length C plus the length A. And using these two expressions, we can solve for length x of AC, which is going to be equal to C times the inverse hyperbolic cosine of 1 plus A over C. Now for y of B, that's going to be equal to C times the hyperbolic cosine of the length x of BC divided by C. And we can also write that as the length C plus A plus the given length of 1.8. And then we can take these two expressions and solve for length x of BC, which is going to be equal to C times the inverse hyperbolic cosine of 1 plus A plus 1.8 divided by C. And if you look back at the figure, we see that the length from B to A in the x direction is 12 meters. And we also know the length from A to C and the length B to C in the x direction. So we can write the following equation using that information. So we can write that 12 is equal to x of AC plus x of BC. And we can plug in x of AC plus x of BC since we figure out equations for both terms. So plugging in those terms, we'll get that 12 is equal to C to x of AC plus x of BC. And we can simplify this. So we factor out a C and we can plug in the value of A. And plugging in A here, this becomes 3.8. So we can take this equation, solve it for C now, and get a length of 6.8153 meters. So if we go back, so we know what C is now. And we can plug it into this equation here, plug in C, and we can solve for this length from B to C. So x of BC plug in the value of C, and then times the inverse hyperbolic cosine of 1 plus 2 plus 1.8 divided by C. And then this will give us a length of 6.9 meters. So we can say that point C is 6.9 meters left of point B. And 3.8 meters below point B. We're now going to solve for the tension of the cable, the maximum tension of the cable at point B. So we're given the mass per unit length. The problem gives us this mass per unit length. And to solve for the tension, we need to convert this to weight per unit length. So weight per unit length is equal to the mass per unit length times the acceleration due to gravity. So we get that weight is equal 0.45 times 9.81, and this will give us a weight per unit length of 4.4145 newtons per meter. Now the equation for tension is equal to W times the length y of B, and y of B we figured out from the previous part. So we can plug in, and we know what W is, so we plug in the two terms to get our final answer. So the tension T is equal to the weight per unit length times y of B, which is 6.8153, the value of C, plus the value of A, plus the given length of 1.8. And this will give us a tension equal to 46.86 newtons.